Okay, dear all, in this presentation, we'll be discussing multidimensional arrays. As you all know that array is a data, collection of data, how the elements are arranged. This is a way. This is the single dimension array. Suppose the size of the array is say 5 and index starts from say 0. Those elements are stored in this way. Okay. 0, 1, 2, 3 and 4. So this is theoretically represented like array name is A whose size is 5 whose size is 5 and uh, the element the third element can be accessed with its index value, that is a of 2 a of 2 a of 2 is the way to refer this element. If we put equal symbol, that is a way to assign a new value, to store new value in that location. You can use that index value to access or to uh, modify the data. This is about one dimensional. Now if I know the address of the starting address, say that address alpha, or in particular case we'll take that address as say 1000, and each element is of type say integer, which takes 4 locations. One data item takes 4 bytes. Then address of this is 1004, address of this is 1008, address of this is 1012, address of this is 1016. So each of these data item takes 4 bytes. This is the base address 1000. It takes 0, 1, 2, 3, 4 bytes. Next item starts at address 1004, 1008 and so on. Okay. Now to calculate the address of this mathematically, we have to use the formula. That means from the starting address alpha, we have to skip these many locations. The index of this is 2, that means 2 locations you have to skip. Okay, that means 2 alpha plus 2. As each of these location takes 4 bytes, internally it will be multiplied by 4. If alpha is known, that is 1000, and 4 into 2 is 8. 1008 is the address of item to be accessed. That is the object of interest, element of interest, the second index. This is a thing in case of one dimension array. Now we'll go for two dimensions. Two dimension array looks like this. I will take dimension 2. In each row there are 4 elements and there are 4 rows. 1, 2, 3 and 4. The array name say it is A. Index 0, 1, 2, 3 and row values are also 0, 1, 2 and 3. This is declared like this. A is an array. Upper bound of the index, that is number of rows, 4. Each row has got number of elements, that is 4. This is the uppermost value. Uppermost value is 4. Index starts from 0. There are 4 rows. Index starts from 0. In case of rows, there are 4 rows and there are 5. There are 4 columns. So this is the size of the array. There are 16 elements can be accommodated here. If this starting address is say alpha, we'll take that alpha value as 1000 or anything. Let it be alpha only. Okay. Now, like before, I want to access this element. This element can be accessed like this: A or a name, the row number 2, and the column number 2. This is a way. This is a way to access. You can copy new element into this place, or you can access this element for the further processing. This is indicated like A of 2 comma 2. Now I want to know the address of this element. Just for the time being, I will take that address as starting address is alpha. That's the base address. Base address alpha is a 1000. Take 1000 as the base address. Okay. Now each of these location takes 4 bytes. This is 1000. This is 1004. This is 1008. This is 1012. This is 1016, 20, 24, 28, 32, 36, 32, 36, 40, 44, 48, 52, 50, 56, and 60. The last address location is 1060. This is the address. Okay. Now this is a way how the data are stored. This is 1004. Each time four locations will be skipped because 4 number of bytes required for this data item. Okay. Now once again I will tell you in this way what is the address of this location: 1000, 1004, 1008, 1012, 16, 20, 24, 28, 32, 32, 36, and 40. 1040 is the address. We'll check it whether we'll get using formula or not. This is the expected address of this location. In order to reach this place, I have to skip all these places from here to here in this row, from here to here in this row, and in this row only two elements you have to skip. That means I have to traverse all these locations, then only I can reach this element. Now that can be written like this: alpha. Anyway, I have to start from the base address alpha into number of columns in the row that I have to skip, and how many number of rows. There are two number of rows that I have to skip. This index value I have to take 2 and 2 in 2. How many columns are there in each of the row? There are 4 columns in each of the row. That means you have to multiply this with this one. You have to multiply this with this value: 2 into 4. Number of rows to be skipped, 2. Number of columns in each of the row, that is 4. So once you do like that, you will be reaching the last column. Now how many rows, how many columns are left? Only 2 columns are left. This one you have to multiply. As this is having each of the locations having 4 bytes, internally it will be multiplied by 4. That is uh, alpha plus 2 into 4 is 16. 16 plus 2 is 16 plus 2, sorry, 4 into 2 8, 8 plus 2 is 8, 10, 10 into 4 is 40. So answer is 40. So 1000 is 1000 the starting address to all these things. You can multiply it by the size. That's also correct. 2 into 4 8, 8 plus 2 10, 10 into 4 is 40. This is a way. Okay. So the formula to be remembered: alpha, the base address, into number of rows to be skipped, this, into number of columns in each of the row, that is 4, plus number of columns internally will be multiplied by 4. This is how to calculate the address of element in case of two-dimensional array where data are stored in row wise, one after the other row. Okay. Now we'll go for the topic multi-dimensional array. Multi-dimensional array is not just two dimension; it can be more than two also. Okay. Diagrammatica I can't represent because it requires one more dimension which I cannot show. So suppose array name is A and the upper dimension for each of this row, like it can be anything. Okay, it can be anything. So we'll take that as upper bound u 1, u second one, and u3, just like a size. The size of this complete array in case of two dimension, if size the upper bound are 4 into 4, 4 cross 4, 4 is size, 4 is the column and 4 is the row. In there are 4 rows, in each of the row there are 4 columns. Number of elements will be 4 into 4, that is 16. Okay, here also same concept. You multiply all the things, u1 into u2 into u3. So that can be represented like this: pi of ui, where I ranges from first to n, first to n. This is a thing. U is the upper bound, pi is the product. So all you have to multiply u1 into u2 into u3. Okay, that's what is given here. If A is an array, upper 1, upper 2, upper n are the dimension each of the things, upper dimension, and the number of elements will be pi of pi of all the things, product of all the things. If the dimensions are 10 and 10 and 10, the total elements will be 100 into 10, that is 1000 elements are. So there are two different conventions in which the elements are stored. One is row major, other one is the column major. Usually row major is used, which is easy. Okay, then we'll go for how to get the elements. Okay, now, so as like before, alpha is the base address, alpha into, suppose I want to know what is that, the address of, say, I, j and k, this element address I need. How to compute it, that is my task. Okay, so alpha into how many rows I have to skip. That means these many number of rows I have to skip, these many number of things I have to skip, into how many columns are there, that is upper bound u2 and u3. U2 and u3 is simple to remember. The first one into remaining two, remaining to upper bound, this one into this one upper and this one upper, both you multiply. Then next one, j, j into this upper bound u3, u3, and remaining, that is k, k. That's all. In case of two dimensional, we'll check it whether it is positive, whether it is okay or not. Suppose the dimension upper bound dimension given is 4 and 4, and the address required is 2 cross 3, 2 comma 3. We'll check alpha, correct, plus 2 into upper bound 4 plus 3, that's what. Okay, because u2 is not there, u3 is not there. This is a formula that you have to remember. This is a formula that you have to remember, which is used to compute the address of that particular element. So as usual, the size to be multiplied. Here I have not shown anything. That's what given in this slide. This slide. Okay. Alpha plus I into upper 1 upper 2 plus j into upper 2, remaining like that goes. Okay, in general, this is a formula to compute the address. Alpha base address plus I naught into upper 1 remaining upper bound, upper 1 upper 2 upper 3, like that. I1 into remaining upper 2 upper 3 upper 4, like that. I2 remaining upper 3 upper 4 upper 5. So in case the last one, I n minus 2 into upper n, last one is just the index value. With this you can compute the address of any location. Generalized formula is alpha plus sigma of j of 0 n minus 1 I into a j, where j j equal to product of upper bound and a n minus 1 is equal to 1. That's all about multidimensional array. Thank you.